freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT from Weather Risk, your commander of chaos, your captain of confusion, your colonel of catastrophe. Let's talk about This Week in Weather, January 33-4. We'll do the first guest map and talk about the upcoming event here for Saturday, some interesting trends about it, and then also go look further into January with some more details. So first, without any more fanfare, there is, that shouldn't be there, huh? There is the 500, there is the first guest map, there you go. And that's what I'm looking at. That's how I see it. So as you can see, the time frame is issued at 7 o'clock to my clients and everybody else, but this year I'm putting it out here for you guys to see now. And you can see the snow mounts here very nicely. There's our ice area here in Southwest Virginia into Northwest North Carolina. And then again, I have my main area of 9 inches and here 9 to 12. So I'm sticking with that. I think that's going to verify quite nicely. And then, you know, there's your 1 inch line. It's just east of Charlottesville, close to Raleigh, just to the south and east of DC, Baltimore, just to the south and east of Philly, and then I guess to Sandy Hook, New Jersey. I have New York City around 3, Long Island around 3. 3 inch line is just to the north and west of DC, right through northern Baltimore, through Charlottesville, down to Lexington. And then you can see the 6 inch line. In the northern Shenandoah Valley, I think a pretty good dump of snow there before it changes to freezing rain on top of it. And then up in Martinsburg, up into Harrisburg, State College, Allentown, Wilkesboro, Scranton, northwest New Jersey, lower Hudson Valley, and much of southern New England. Pretty good dump of snow. Not a huge event, but pretty good dump. There's your start times for precipitations. You can see, the green line here is 1 p.m. and you can see the black line is 3 a.m. Saturday. Then 7 a.m. is the brown line here. You can see that. Let me call it my marker here so you can see what I'm talking about. So this is 1 a.m. This is 3 a.m. Saturday. This is 7 a.m. Saturday. The green line here is 1 p.m. Saturday. Then 7 p.m. it's all the way up into central New England and New York State. So there we go. And then here, I'll take this out. You can see the ice times as well. So, again, the ice I think is significant, so I'm kind of mentioning it. I think there's a lot of ice coming to these areas in here. I've posted some of the ice maps, and if you get a chance, you can take a look at them. They're pretty impressive. The other thing is the temperatures Friday morning going to be around 20 degrees in many areas in Southwest Virginia and Northwest North Carolina, especially Southwest Virginia. And even Saturday morning when the precipitation starts, they're 26 and 27 degrees. So it's quite a bit of frozen precipitation coming here. The problem is that the rain snow line, the 0 degree 850 isotherm, it is too warm. It's not cold enough. As soon as you get south of Blacksburg, the 850 temperatures are too warm to support snow. So you get liquid precipitation falling out of the clouds at 28 degrees, and that's freezing rain. Now, one of the things I want to talk about here is how this thing has been impacted by the overall El Nino and the pattern. Some other people have mentioned this as well, so let me call up my marker here so you can see what I'm talking about. Let me change the color here. Okay, so then this was the upper air map from January 1st, 500 millibars, right? And you can see this is our shortwave. Look how potent it looked. Okay, close 500 low in Illinois. You can see the negative tilt. See that angle here running northwest to southeast, right? There's another system in California. Now that was this was valid for this Saturday night, 7 p.m. This is the update as of this Wednesday evening, 18Z. This shortwave is now this piece of crap over here. What? See how this dramatically changed here is here? What? Are you kidding me? That's a huge change. And the other difference is, see this piece of energy that was in California? It's now down here in Texas. See, you had there was one short wave in Pacific Northwest, then this one. And maybe this little piece right in here. Look what's happened. This little piece in the plain states has become this monster shortwave in Texas and Oklahoma. And this thing deepened, this forced a ridge to form in the southeast states and lifted our shortwave up to the north and weakened it. This was supposed to go straight through the mid-Atlantic. Didn't do that. This piece of energy dropped down to Texas, and you had a shortwave right here. And now you're getting a ridge in the southeastern states, and that kills this system, so you get this little pissant little thing right here. And you can see it even more. Let me show you just the eastern U.S. region here. Okay, upper air map, January 1. See the shortwave right here? See how it's negatively tilted running northwest to southeast, right? From Illinois to Georgia. Close 500 local vorticity fields in this, enormous. Now look at this thing. That's the same system. And the main difference is this new shortwave in Texas and Oklahoma. That's what's killed it. This system here has forced this system and weakened it quite a bit. The other feature, again, sometimes the old-time method is the best way. As many of you know, you have to have a cold high pressure to the north when you have a southern low. Because a southern low, in addition to bringing the moisture, which you like for big snow, also brings up milder temperatures. So you have to have a counter, something to reinforce the cold air as the mild air comes up from the Carolinas and Georgia. We don't have that. There is a cold high to the north, but this high is way too far to the north. Look how far to the north it is. Okay, it's not, this high is supposed to be in the Great Lakes here, or in southwest Quebec, or New Maine or something like that. This thing is too far north, and the air mass with this front is not Arctic. Okay, it's polar, but it's not Arctic. And that's the problem. Not enough cold air here. This is the Canadian model from midday. You can see the Canadian model's been, no, this is the European. Sorry, I jumped the gun here. This is the European. You can see the track of the European. I superimposed it here. It goes northeast, it goes through southeast Virginia. You can see that, and then to Delmarva. That's too far to the north, given the lack of cold high pressure to the north. So the Shenandoah Valley mixes and goes over. And the European model from this morning, 6Z run, the 12Z run, the 18Z run, are all pretty warm in terms of the mid-levels. So the European has been very consistent about that. Now the ensembles are not quite that warm, but they're also in the general direction. So that's why, if you can make an argument that DC might not see any snow at all, maybe like 1-2 hours of snow and that's it. It's still up in the air. We don't know about that. Same thing with Charlottesville. You could make an argument Charlottesville gets 3 inches of snow or 1 inch of snow or mostly just freezing rain. They're still right on the edge. And then you can see what happens here. Now this is the, like I said, that was the European from midday here. This is the European Ensemble 18Z. Now the black line here is the rain-snow line at 1 o'clock on Saturday afternoon. You can see it's still south of DC, close to Charlottesville, it's in the Shenandoah Valley. So everything south of that line is liquid. In this case, this is freezing rain right in here. Huge freezing rain event, really big. And then this is 7 p.m. Sunday. Now the black line, you can see it's pushed through the northern portion of Shenandoah Valley. Martinsburg is still snow. Winchester is still snow. Elkton is still getting snow. A lot of freezing rain in this Shenandoah Valley here. And then DC is like wall rain. The line goes up to Philly, but it doesn't go north of it. Now the operational run it does, the ensemble does not, and the line stops short of New York. So the 18Z European keeps New York City mostly cold enough for snow. The problem is the temperatures on Saturday afternoon into the evening hours go to 34, 35 degrees in New York City. So even though you're cold enough for snow aloft, at the ground, you're not. The same thing in Philadelphia. You're too warm. So that's really a problem. And then you can see the 18Z here. Again, this is 1 o'clock Sunday morning. The black line, notice here the line is actually going back south here in the Shenandoah Valley. So it might go back to all snow here. So that could very much happen in central Maryland, Winchester, Leesburg, maybe even Dulles, in the northern portion of the valley. Okay, and you see it goes just north of Philly, but it stops south of New York City. But again, your surface temperatures are too warm here on Long Island, New York City. You're 34, 35 degrees. That's what it looks like to me. Now maybe that'll change, but that's what it does. And you can see the north low, again, pretty far to the north. If this was coming more like this, it would be better for New York, but then you're getting less precipitation. So, okay. This is the 18Z European. Now, notice it's got about 3 or 4 inches in New York City. Again, I'm not sure that's going to happen at 34, 35 degrees. So again, that's why you can't look at these maps at face value. You have to look at the soundings and the surface temperatures, and it's too warm. New York, DC, an inch of snow. Baltimore, 2 or 3 inches. Philly, 3 or 4 inches of snow. Not at 34, 35 degrees. Not going to happen. Charlottesville, was that? No, 2.7 inches. Maybe an inch or two. Then you can see Staunton getting 4.5 inches. Roanoke, 2.5 inches of snow. I don't think that's right. I think they're mostly freezing rain and sleet. I don't think that's the right. But you can see here, look at central Pennsylvania and then central Maryland. Decent snow event up into New England. A lot of snow in New England here, and the Catskills in northern Jersey. Now, the Canadian has been the most bullish on the sleet and freezing rain. A couple of days ago, they were very bullish on the freezing rain in northwest North Carolina and the freezing rain and sleet into the Shenandoah Valley, and then, the northern area staying all snow. So the Canadian, I got to hand to the Canadian, has been very consistent here. A lot of people haven't paid attention to it. You probably should. I think this is a very viable solution here. I like the solution a lot. You can blow it up here. See what the Canadian's doing here? Now, this is Saturday, 1 o'clock. A lot of sleet and freezing rain here. That has freezing rain fairly close to Richmond. I'm not sure about that, but definitely, Farmville, Lynchburg, Roanoke, a lot of freezing rain. Temperatures are going to be really cold in those areas. And then to get sleet, the purple stuff, into Staunton, and then the northern Virginia Piedmont, Orange, Madison, and then snow up the northern areas. And then, interestingly enough, look at that. I'm doing this front. You see what happens. As the low gets cranking, the sleet line, the change line stops. And the northern Shenandoah Valley, that purple color in the blue, that's super heavy snow. So the northern half of the valley gets pounded, as does western and central Maryland, south central Pennsylvania, the eastern panhandle of West Virginia. So I think that's a viable solution. I like that a lot. This is the 18Z GFS, and it's the same sort of thing. See, brings it to the north and then goes up there. You can see it and it's essentially the same thing as we saw before. So what I wanted to show you here was the GFS maps and the snowfall maps. So this is the GFS at the 12Z, and this is the 18Z. And the 18Z seems to have increased the snow a little bit. So we'll see if that trend holds. It might. But the other thing I want to point out here is, I'll blow this up so you can see it. Look at the cutoff here. Very sharp cutoff on this snow. Okay, so for example, DC gets 1 inch of snow, maybe. Okay, but Frederick gets 6 and Hagerstown gets 10. Philadelphia, 3 or 4 inches, but Reading, 9.1. Really sharp cutoff. 3 inches in New York City, Newark, almost 7. And then, Northwest Jersey, 10, 11 inches of snow here. Very, very, again, and in the same thing. Just east of Charlottesville, nothing. This model has Charlottesville as 5 inches. I doubt that, but maybe. And then Staunton gets 9, gets pounded. So, again, that's a pretty nice cutoff here. And the same thing, Manassas, nothing, but, Dulles, 5 inches. So, okay. That's the event. So that's my presentation for the first guest map. Again, after this, we'll use a first call map and then a final call map. And of course, the snow clients and the other clients get the information hours and hours before you see it on the Facebook page or on these videos. Just to let you know about that. Okay. And with a lot more detail and explanation, by the way. All right, let's talk about what's happening longer term in the pattern here. Since this is a This Week in Weather, we're going to talk about additional stuff. So here's our Atlantic side of the teleconnections. We have the Arctic Oscillation, the NAO. Typically, if you like snow and cold in the eastern United States, what you want to see is both of these teleconnections, these jet stream patterns, the Arctic Oscillation to be strongly negative and the NAO to be strongly negative. That's exactly what happens. Now, of course, the useless and pathetic operational GFS does, things to the positive by January 22nd, but that's wrong. You want to use the ensembles and the other better models here, and they keep it all very strongly negative. On the Pacific side, the Eastern Pacific Oscillation, the Alaskan Ridge, is the black dots here show right now that it is positive, and it stays that way on January 9th, 10th, and then it crashes negative, and that's when you get your big your cross-polar flow here. So that's when it starts turning really, really extremely cold. And then the Pacific, the PNA pattern, here it's positive, but all this energy coming into the West Coast, it keeps it negative. So the El Nino is bringing in the troughs to the West Coast, but we are getting a lot of cold air coming down from Canada. So this is the pattern here for next Monday, Tuesday. And you can see we have this huge upper low, which comes in from the West Coast and the Eastern Pacific. The black line shows the alignment. See how it's running north to south? It's a gargantuan closed monster upper low centered in Texas, Oklahoma panhandle areas, right? Now, that system is going to swing towards the Great Lakes, and as it does so, it will develop a severe negative tilt. Look at this monster. This is January 10th, and you can see the negative tilt right here Look at this baby. Okay, that's where the upper low is gonna. That's where the surf low is gonna be. So this low is gonna go boom as it goes towards the Great Lakes, and it's gonna cause a lot of problems for everybody in the Great Lakes and the East Coast. Let me show you what I mean. So this is the GFS model. This is the 18Z run. There's the intense low 993, 983 here, another low, triple point here. There's this. I would not be surprised if this was a severe thunderstorm outbreak with tornadoes in the southeastern states. That would not surprise me at all. Now we do have a cold high to the north, but it's, there may be some wedge here in the valley in Virginia and western Maryland, but for them it looks fairly minor to me. Look at these howling south winds. I mean, these winds are just going to blast the hell out of that cold air. Meanwhile, in Chicago and Missouri and eastern Iowa, they're getting a blizzard. So don't be surprised if there's a blizzard watch or warnings put out for the Midwest here next Monday or Tuesday. That wouldn't surprise me at all. There's the GFS. Thing goes in the eastern Great Lakes, 977 or lower, just a monster storm. And you get high winds here. I'm sure you have blizzard conditions in Chicago, or at least close to it. Same thing in the Great Lakes. Would not be surprised if there was a blizzard warning issued for this event. Would not surprise me at all. Here's the European, same thing. Texas, Oklahoma, Missouri, again, and then the pressure gradient becomes extreme here on the East Coast. Very strong winds. And then would not be surprised if we saw winds to 50 miles an hour or higher, especially on the coast. And then the system bombs out in Michigan. And this is an Arctic front. You can see the Arctic air coming eastward here, driving the cold air behind it. All right, longer term. Now, things get interesting. This is the European here, the operational European on January 13th. So we have a monster NAO here. Remember we talked about the NAO being strongly negative? Okay, so this is what it looks like on the maps. See this monster feature right here? Let me blow this up a little bit so you can see it. Okay, here's a negative NAO, right? Now, this is your ridge. So we have this huge piece of energy which comes down, and it swings around through the Rockies, the western United States. Again, this will be a blizzard for somebody. And as it swings towards the East Coast, what's it going to do? Now, the basic laws of meteorology and physics say it's going to have to pass underneath the block, but the models want to take this system through the Midwest, and that makes no sense to me. That just makes no sense to me at all. And I'll show you why. So this is what I'm talking about. This is 234 hours out. So this map here in the upper, let me blow this one forward here. Okay. So this is, day 10. So this is January 13th. Here is January 13th. It's got a little low here in the Ohio Valley. It looks too far to the north to me. Maybe I'm wrong, but that's what it looks like to me. And then you can even see this some more. And then this is January 12th on the European. This upper air map, that makes no sense to me. There's going to be a front going through here, sure, but I don't know why all the energy is up in the Midwest. That makes sense to me. And there's another one here in the Great Lakes. In the Great Basin. This is the GFS for January 15th. Again, why is the low this is a blizzard for the Midwest also. Why is it in Iowa? Now you got an ice storm going on here, in the mid-Atlantic states, but the upper air pattern, this makes no sense to me. I don't understand why it's doing that. So I don't have a lot of confidence in anything past day 7 at this point, day 8. Now eventually what happens is we get the big polar vortex split. Let me bring this map forward. And now this is what's important here, because we have the gigantic Greenland block. The polar vortex drops from central North Canada down to James Bay right here, and that unleashes an Arctic outbreak. So this is extremely cold air here, and there should be some sort of storm along the frontal boundary. January 14, 15, 16, 17, something along these lines here. Now, again, the models aren't showing it, and when they do, it's all up in the Midwest. I just don't think that's the right solution, given this monster block which develops here by the middle of January. So we'll see how it shapes up and how it goes on, but that's how I see it. Anyway, this is meteorologist DT from Weather Risk. I will see you over on the Threads page, the Twitter page, the website, and over on the Facebook page.